Ever wonder how trains move so smoothly on long tracks? It's not just the engineering of the trains themselves, but also the meticulous work done on the tracks they run on. The secret is rail welding. This process ensures that the tracks are continuous, eliminating the gaps that can cause so many issues. Imagine tracks with gaps, clickety-clack, noisy, bumpy, and bad for the tracks. These gaps can lead to a rough ride and even damage the train over time. Rail welding gets rid of the gaps, making a smooth, quiet ride. This seamless track is not only more comfortable for passengers, but also more efficient for the trains. This means less wear and tear on the train, and the tracks is also safer. Regular maintenance becomes easier and more predictable, reducing the chances of unexpected breakdowns. Fewer gaps mean fewer chances of a train going off the tracks. Safety is paramount in railway operations, and welded rails play a crucial role in ensuring that. We'll look at 3 ways to weld rails: contact, thermite, and gas pressure welding. Each method has its own unique advantages and applications. Get ready to learn the science that makes trains run. From the physics of metal expansion to the chemistry of welding, we'll cover it all. Contact welding uses electricity to join rails. This method is essential for creating continuous welded rail tracks, which are crucial for modern railways. By using electricity, the process ensures a strong and durable bond between the rail sections. Mostly done in factories, it uses electricity to melt the ends of 2 rails. The high temperatures generated by the electric current cause the metal to reach a molten state, allowing for a seamless fusion. Then, the melted ends are pushed together. This step is critical as it ensures that the molten metal from both rail ends mixes thoroughly, creating a uniform and strong joint. Flash butt welding is a common type. This method is favored for its efficiency and the quality of the welds it produces. It involves a series of short, intense bursts of electricity to heat the metal. The ends touch and a big jolt of electricity makes them super hot and melty. This intense heat is necessary to ensure that the metal reaches the right consistency for welding. Then they're squeezed together, and the melted metal mixes. The pressure applied during this step is crucial for eliminating any impurities and ensuring a solid bond. This makes a super strong joint, almost as strong as the rest of the rail. The integrity of the weld is vital for the safety and longevity of the railway tracks. It's smooth, perfect for fast trains. The seamless joints reduce wear and tear on the train wheels and tracks, allowing for higher speeds and a more comfortable ride. But the equipment is big and pricey, so it's mainly for factories. The investment in such machinery is justified by the high quality and durability of the welds produced, making it a worthwhile expense for large-scale rail projects. Imagine heat so strong it can melt steel. That's thermite welding. It uses a powerful chemical reaction to join rails. Perfect for working outside, where you need tools that are easy to move. Thermite is a mix of aluminum powder and iron oxide. When lit, it gets really hot melting iron. This melted iron flows around the rail ends, melting them and making a strong weld. It's portable, but the heat can change the metal around the weld. Gas pressure welding is another way to join rails. It uses heat and pressure, good for work in factories or outside. A hot gas flame, usually oxygen and acetylene, heats the rail ends. When they're soft, they're pushed together. This makes a strong joint. It makes good welds with little damage to the surrounding metal, but it needs skilled workers to do it right. Rail welding is a crucial process in maintaining the integrity of railway tracks. It ensures that the rails are joined seamlessly, providing a smooth and safe journey for trains. However, despite its importance, problems can happen during the welding process. These problems, if not fixed promptly, can make the tracks unsafe for trains to travel on. Defects in the welding can lead to serious accidents, causing harm to passengers and damage to the railway infrastructure. Therefore, it is essential to be aware of these common defects to keep the tracks safe and strong. Regular inspections and maintenance are key to identifying and addressing these issues before they escalate. One common problem is porosity, tiny bubbles that form in the weld. These bubbles can compromise the strength of the weld, making it more susceptible to breaking under stress. These bubbles weaken the joint significantly, reducing the overall durability of the rail tracks. This can lead to frequent repairs and potential safety hazards. Another common defect is slag inclusion, bits of non-metallic material that get trapped in the weld. These inclusions can create weak points in the weld, making it less effective in holding the rails together. To address these issues, India has established strict rules and standards for rail welding. These guidelines are designed to ensure that the welding process is carried out correctly and safely. Following these rules is crucial to keep our trains safe and running smoothly. Adhering to the standards helps in maintaining the quality of the welds, ensuring the longevity and reliability of the railway tracks.